Okay, good morning, everybody, and welcome to our live stream for today. Yesterday we talked about the summary of the probability unit. Today I would like to spend some time on going over those probability unit review. So, go through the full solution so that you may uh, be able to figure out um, how to do them. If you're stuck on some questions, um, I just want to let you know that there's no live chat going on right now, and it won't be up. So if there's a question that you want me to go through from previous lessons, I will go over that with you. Just send me an email. So for today, I'm gonna just focus on the probability unit review. That's found on page 24 on to 25. So let's just read some of the questions first before we just jump into this full solution. So the very first one there, it says there are 20 jelly beans in a jar and 12 of these jelly beans are red. Now, the only thing that we know for sure is that there are red, and state the P red. So it means what is the probability or the chance that it's being red? So number one, probability that it's going to be red. Okay. Well, we know that there are 12 reds in the jar. So it's going to be 12 out of 20, because the probability is this is the event. The event is having the red, and then how many are reds? And then the 20 talks about how many are the possible outcome or total possible outcomes. Okay. Well, the total possible outcomes would be the reds and then whatever's the rest. So that's number 1A. Number 1A. Now let's take a look at letter B. Letter B. Letter B says, what's the probability of not red? What is the probability that it's not red? Remember, in a big jar full of jelly beans, 12 are red and how many are not red? So this is going to be the complement of red. So if there's 12 that are red, then that means it's going to be just 8 are not red. So 8 out of 20. So this one tells us how many are not red. And then the 20 tells us how many are total possible outcomes. Okay, so total possible outcomes, that includes the reds and then the ones that are not red, jelly beans. Okay, now this is kind of interesting. When I looked at this question, I was like, make me kind of stop and think about it for a second. What is the probability that it's blue? What is the probability that it's blue? Now, in the question, there is no indication of what the other colors are. We know that they are not red, but we don't know that they are actually blue. So in this particular case, we can say 0 out of 20. Because in this particular question, we don't know what the multiple colors are, or what about the not reds. So how many blues? Well, in this particular case, no specific mention that there are blue. And then 20 would be the total possible outcomes. So that means total possible jelly beans. Okay, so that one is pretty straightforward. Um, so thinking about the probability part. Okay, let's take a look at number two. Let's read the question first, and you probably have it in front of you. Um, I'll just put it on just in case so we can read it together. There are 450 students in the school. 100 are in grade 12s. 120 are in grade 11s. And then the rest are in grade 10. Okay, so this particular scenario tells us that this is how many there are in the school. These are how many grade 12s. This is how many grade 11s. And then the rest are grade 10. Well, how many are grade 10s? So the very first thing that we have to do is to figure out how many are grade 10s. So state how many grade 10s are in this school. So in that particular case, letter A, number of grade 10s. Okay, we know that there's 450 students in total. Now, if we take away the grade 12s, which are 100, and if we take away the grade 11s, which is 120, okay, so that gives us 230 students. So that means 230 students that are in grade 10. Okay. Let's take a look at the next question. The next question says, if a student is selected at random, so we pick a student at random, determine that the probability of the student is in grade 12. So I'm just going to write this down. What is the probability? And then followed by the event. What's the event that we're talking about? We want to have a probability of grade 12 students. Probability of grade 12 students. So this is our event. So because we're talking about probability, we have to look, well, how many are grade 12s? How many are grade 12s? There's going to be 100 of them out of, okay, because it's a probability, it's going to be total possible outcome. So the total students would be 450. So on the test, or you can just write this down. Okay, you can just write that down. I know that on my solutions and on my notes, I've been writing down like what this number means, but on the test, you just write this down. Okay, it's just that this extra stuff that I'm doing in here, right? Explaining where the 100 come from, where the 450 come from. That one is just for you to, just in case you're wondering where did that 100 come from. So 100 would be how many grade 12s? I'll just put GR12. And then how many total possible outcome? And when we talk about all total possible outcomes, so that includes all the total students, that's grade 10, 11, and 12. Okay, so that's number 2A. And I'm just going to read number 2C. Determine that the probability is not grade 11. So this one here, so what we're trying to figure out is the probability that the student is not grade 11. So this is the event, not grade 11. This is the event that we're trying to figure out, right? Not grade 11. Well, how many are not grade 11? So in this particular category, how many are not grade 11? We have to consider the grade 10s, because grade 10s are not grade 11s, and also the grade 12s, because grade 12s are not grade 11s. So not grade 11 talks about everybody else that's not grade 11. So it includes the grade 10s and the grade 12s. So how many grade 10s are there? We figured out the grade 10s is 230, and then the grade 12s, it was stated as to be 100. So that's going to be 100 plus 230. So it's going to be 330 out of everybody else, because that's for the probability total possible outcome. So this one, I'm just going to write this down. Where did the 330 came from? That came from how many not grade 11. Okay, so i.e., so we're looking for grade 10s and grade 10 or grade 12 students. And then 450, we already know that one. That's total possible outcome. So that means total possible outcome. That means total students, all of them. Okay, so that's question number 1 and number 2. Just basically talking about the probability or applications of probability. That's what I'm thinking about. Okay, so so this particular case, and I'm looking at this one in here. When we looked at expected value, we looked at in two different possible formula. Okay, so when we talk about expected value, okay, before we get into this one here, when we talk about expected value, we actually have two formula that we use. So the first formula is the one that we were using from our notes. Expected value, I'll just put EV is equals to probability of win, or whatever that outcome is, and times how much was won minus cost to play. Okay, so for the most part of our expected value questions were this type of question on our notes. Now, the other expected value formula that was outlined on our formula sheet is this: probability of win times the gain minus probability of losing times how much money was lost. So this is the other probability, expected value: win times gain minus probability of lose times how much did we lose. So that's the formula. Now let's take a look at this question, and then we can decide which one would be the one that we're actually going to use in this particular case, because sometimes we can use this, sometimes we can use this, or in other times we could use either one. So let's see here. And I know I didn't show you from the notes that we took. I didn't give you the notes for this one. Okay, so let's just go over it together. So it says here, a game is played where the coin is tossed. If it lands heads, you are given $10. So that's the money that you gain. If it lands tails, you have to pay $5. $5. So in this particular case, there is no mention of how much was the bet or how much does it cost to play. It talks about how much you win and how much you have to pay if you lose. So in this particular case, we're going to be using this formula in here. So for number 3, I'll just put here for number 3. Bring it down there. So we're going to use this formula over here. Expected value is equals to probability of win times how much am I going to gain from this thing? Net gain. Probability of lose times how much did I lose? So probability or the chance of winning, because this is a coin toss, the probability of landing on the head would be 1/2. 1 out of the 2 chances of getting the head. And how much am I going to gain? Well, if I get the head, I'm going to gain $10. I'm going to gain $10. Minus, okay, what's a probability that I'm going to lose? Well, I have a half chance of losing because the coin could either turn head or tail. So that's going to be a half chance of losing. And if I lose, I have to pay $5. So times 5. So working this out, so a half times 10 would be 5 minus a half times 5, which is $2.50. So it's going to be $2.50. I'm just going to show you how to type that into your calculator if you're just wondering. So if you were to type this into your calculator, you would go 1 divided by 2 times 10. Okay, so that's that part there. And then I got to do subtraction. Subtract 1 divided by 2. So that's 1 divided by 2. So that's the 1/2 times 5. And then I get 2.5. Now, why did I put 250 in here? Because this is the expected value gaining. We're talking about money gained in here. So we're going to put a $sign at the front and 2 decimal places after. So $2.50. So that's letter A. Now let's take a look at letter B. Do you think this is a game you should continue to play? I would say yes. Yes. Because, and then we have to explain why. Because the expected value, I'll just put EV, is positive, which means if I play, I am expected to gain money, not lose money. Okay, it's a positive gain, positive value. That means over time, I am expected to gain money for that one. Okay, and then let's take a look at letter C. Letter C, it says, if you play the game 100 times, calculate how much you expect to gain or lose. Well, now it's not guaranteed that we're gonna get this. So this is still an expectation. We can expect approximate how much we could possibly gain or lose. So if we play 100 times, so 100 times, and then we're expected to gain $2.50. So that's going to be $250. Oh, okay, that's pretty good. Okay, so those are the first 3 questions, and then we're just going to move along. So we have time for the other ones because we have 11 of them. A spinner has 6 equally sized segments. So this is question number 4 on your book. You probably have it in front of you, and says a spinner has 6 equally sized segments. Each segment is a different color. There's red, orange, yellow, green, blue, purple. And those are all shown. You spin the spinner once. If the color that you spin is yellow or green, you win $20. If the color that you spin is not yellow or green, you lose $10. So again, this is an expected value. So I'm going to bring this up here. So which one can I use in here? Well, it sounds like it's this one in here, because if I win, this is how much I'm going to gain. If I lose, then this is how much money I'm going to lose. Whereas this one here, they don't have that mention of those information, right? It just says probability of win times loss minus cost to play. We don't have this information, but we do have all of these information. So let's see. Probability of win times how much I'm going to get out of it if I win, minus probability of lose times amount that I'm going to lose. Okay, so I'm just going to spin, no, not spin, show you this. It says here, if the color that I spin is yellow or green, well, what's the chance I'm going to get yellow or green? There's two yellow and yellow or green, 2 out of everything. So 2 out of 6. So probability that I'm going to win, that means if I'm going to get yellow or green, is 2 out of the 6. And if I win, I'm going to get $20. And then I'm going to follow this one here. What's my probability of losing? Well, I will lose if I don't get yellow or green. I will lose if I get the other colors, which is 4 out of 6. And how much money am I going to lose? I lose $10. So let's enter that on our calculator. So you would type that in as 2 divided by 6 times 20 minus 4 divided by 6 times 10. Oh, $0. Okay. So the expected value is $0. So I'm expected to just break even. That means I'm not going to win and I'm not going to lose either. Okay. So over time, if I play, this is my expected gain or loss, which is nothing. I don't expect to lose or gain. Okay, so I'm just gonna have that up just in case you are still writing that piece. I'm gonna go on to question number 4. Question number 4. No, 5 I meant. I just did 4. Number 5. So question number 5. This looks like an expected value again. Jack is considering buying stock in a new company that manufactures exercise equipment. He is thinking of investing $500. If things go well, he could make a profit of $2,000 from this purchase. If things go badly, he could lose all of his investments. So there is a 40% chance that things will go well. Okay, calculate the expected value, and is the expected value guaranteed? Explain. So that's a question. Now, what does that say? This is an expected value question. Now, again, if I bring up this expected value formula, it's it looks like I have probability of win, and then the chance that I'm going to win is given. If I win, this is how much I'm going to gain. It actually doesn't have the amount, the probability of lose. And I do have this part here. But we could figure out the probability of losing, because if I know the probability of winning, which is 40%, then the probability of lose is 60%. So this first expected value formula is not going to work in this case, because there is no cost to play in here. Okay, so I think we could turn it out into, we could turn it into either or in this particular case, but I'll just use the second formula. EV is equals to probability that I'm gonna win times how much am I gonna gain out of that profit altogether, minus probability of losing, and then how much money am I gonna lose. Okay, so probability that I'm gonna win, they said it's 40%. So 40%, I could go 40 out of 100. 40% means 40 out of 100 times gain. I'm gonna gain $2,000 from this, minus probability of losing. Now, if I in 40%, that means I'm gonna lose 60%. So 60 out of 100. And if I lose, I'm gonna lose all of my investment. I'm gonna lose my 500 bucks. So calculating all that information. So 4 out of 100, so 0.4. I got 500 bucks. Okay, so my expected value is $500. Now, the interesting question is letter B. Is this guaranteed? And there is no such thing as guarantee. Not guaranteed to gain. Although we expect to gain from this, and that's basically what probability is. We kind of calculate what it could be, but there's different ways that things can go wrong. Like if I invest in this whatever exercise equipment thing, and then the pandemic happens, then there is no winning for me. So even though calculating it, my expected value is positive $500, so I'm expected to gain. There's no guarantee of actually gaining or losing. Okay. Okay, so we could either, there's no guarantee to gain or lose, but the thing is, that also she, it might be, this person might be gaining more, right? Or gaining less, or losing more. So there's no guarantee in that case. So let's take a look at number 6. Number 6 is quite a big one, because it's a whole bunch of letters A to F. So it says here, on a 12 table of 12, on a big table are 12 covered plates. Each plate has food in it. It follows as follows. 3 plates have steaks, 5 plates have fish, 3 plates have mac and cheese, and 1 plate has chocolate cake. So I'm just going to write that down. So I'm not going to go back and forth in here. So 3 steaks, 5 fish, 3 mac and cheese, and one cake. So how many is that on a big plate? Okay, so how many is that all together? So 3, 5, 8. So that's 8, 11, 12. So there's 12 all in all. So let's take a look at letter A. It says 6A says, what are the odds of picking a chocolate cake? Odds of picking chocolate cake. Okay. Now, because we're talking about odds in here, odds in favor of baking a chocolate cake, so we're going to look at the ratio between cake is to not cake. Okay, so if we break it up like that, it's going to be super, super easy to understand. So cake, there's only one. How many are not cake? Well, these are all not cakes. The steak is not cake, fish is not cake, mac and cheese are not cake. So that's going to give us 11. 1 is to 11. Okay, and let's take a look at B. What's the odds of picking fish? Okay, now again, because this is the odds that we're talking about, in here of picking the fish. So what we're going to do is we're going to look at the ratio of fish is to not fish. Okay, so this is if we write it like that, it's simple. So how many are fish? There's 5. How many are not fish? Not fish is 7. And all of these add up. If we're doing the odds, all of these add up to the total plates there are, right? So this adds up to 12. Look at letter C. Now, letter C has turned to become a probability question. Letter C is the probability of picking a steak. Probability of steak. Okay, so probability, and then this is the event that I'm talking about. The probability of getting a steak. Well, how many steaks are there? 3. Now, because it's a probability that I'm asked here, so 3 out of all of the possibilities, total possible outcomes. So 3 out of 12. Okay, so this is steak, and this is total outcomes. Means all of possibilities. Now letter D, what's the probability of picking steak or fish? Probability of picking steak or fish. Now, generally in math, the word or means adding it up. So steak or fish together. Okay, we don't do it separately, we add them together. So steak or fish, that's going to give us 8 because there's 8 of them out of 12. Okay, so 8 out of 12. Take a look at letter E. Odds of steak. Now it's switching back to odds. Odds of steak. Going back to odds in here. So odds of steak, I'm going to set it up. Steak is to not steak. Okay, so how many are steak? Steaks are 3. And how many are not steak? That's going to give us 9. 3 is to 9. And then finally, letter F. Now, they got odds. I got to pay attention to my wording here. against stake. Now this word against, that means we're gonna look for the against the stake. So that means against the stake means not stake is to stake. Okay, so because it's the words against, I'm going to start with the not, the opposite. So not stake, there's 9 of them, is to 3. Okay, so that's a really, really good question. You're going to have a question like that on your test, certainly from odds to probability, probability to odds. And yeah, so make sure that we're comfortable with that one. Okay, now where are we at? We are number 7. Okay, so we're doing quite well in here. Number 7. Bring this up. The probability of seeing the northern light is 3 out of 10. Now, look at what they had in here. Probability of seeing the northern light is 3 out of 10. But because this is a probability, that means 3 is see northern lights, and then 3 out of all possibilities. So the question that they're asking for is, what are the odds of seeing northern lights? Okay. We know that probability of seeing, I'll just put NL, northern lights, is 3 out of 10. So that tells us this is how many times have we seen northern lights? 3. See northern lights. And then this one are all possibilities. And then all possible outcome includes seeing the northern lights and not seeing the northern lights. So how many did we not see that? How many times did we not see the northern lights, or the chance that we're not going to see? It would be 7. So odds of seeing the northern lights, see northern lights, is to not see northern lights. See, we know it's 3, is to 7. 3 is to 7. And then letter B, state the odds against seeing. Against seeing northern lights. So because it's the word against, so we're going to start with not see northern lights is to see northern lights. So that one would be reversed. So starting with 7 is to 3. 7 is to 3. Okay, so we're doing really, really good in here. So we are already on number 7. Let's move forward to number 8. So we got 4 more questions to go. If you didn't get a chance to write everything down, don't you worry. I will post this right away as soon as we're done this live stream. Okay, number 8. The probability of Winnipeg Jets beating Chicago Blackhawks is 25%. State the odds. So I'm just going to write that down. Probability of winning, Jets winning, is 25%. Okay, so because this is Jets winning, it's 25%. Let's put it into some kind of a fraction in here, because 25% means 25 out of 100. So if there's 100 games, they're going to be winning 25 games out of 100 games. So this is Jets win. And then this is the possible outcomes, all possible outcomes, thinking about the maybe all possible number of games. Sorry, you can't see that. Okay, so bringing it to 25 out of 100, now we can see what's the denominator. Now, within all these possible outcomes, this includes the Jets winning and Jets not winning. So the question is odds, Jets. I know it says here Jets in favor of beating Chicago. Oh, that means, well, if they beat Chicago, that means Jets win. Just make it a little bit easier. So odds, that would be Jets win is to Jets not win. Okay. So Jets win, that would be 25. Jets not winning. Remember, if there's 100 all possible games, 100 all possible outcomes, and that means 75 will be not a win. Okay. And letter B, state the odds against Jets. Odds against Jets winning. So because I gotta pay attention to my wording in here, odds against. So that means I'm gonna go against Jets winning. So that means not win. To comparing it to as a ratio of Jets winning. Okay, so not Jets winning, that's gonna be 75. And Jets winning would be 25. So it's reversed. Okay, let's take a look at number 9. Oh, well, I can see the pattern going on here. It's all about Winnipeg Jets going. The odds that Jets will win the next game is 6:5. Okay, so this is what's given. Odds that the Jets win is 6:5. Now, what does that mean? How do we interpret this one? That means because this is the Jets winning, this number 6 is the win, Jets win. And then this number here is Jets not win. Okay, so that number 6:5 is the ratio of winning and not winning. So it's odds is really a comparison or the ratio of what's going on in here. That's the given. The question is, what is the probability that the Jets will win? Probability that the Jets will win. Okay. Well, how many ways that they can win? 6 divided by, because this is a probability, divided by all possible outcome. All possible outcome would be them winning and not winning. So it's 6 out of 11. 6 out of 11. Okay. Number 10. Last 2 questions. In a school of 384 students, the probability of that a random student going to post-secondary school is 0.63. Calculate how many are expected. So in this particular case, it's, or when we look at this one here, expected. Now, because the word expected in here, we actually saw expected value or expected number in 2 different places in our booklet. In this particular case, this is not an expected gain or loss. This is expected of how many are we gonna have given this probability. So in a school of 384 students, The probability that the students is going to go to post-secondary is 0.63. How many are we expecting to go to post-secondary? So expected value in this particular case is 0.63 times how many are there? 384. Okay, so the probability in this particular case, the probability is expressed as a decimal times how many are there altogether. So 0.63 times 384. I'm going to get 241.92. Now, because we're talking about how many students, we can't have 0.92 students, right? We can't have a portion of a student. So in this case, we would have to properly round this off to 242. 242 students. Okay, and last but not the least, a technology company has a theoretical probability. Okay, this is really interesting because this is the last one we've never seen before. It has a theoretical probability. Okay, what it should be is, sorry, let me read that again. The technology company has determined that the theoretical probability of a tablet being defective is 0.014. I'm getting ahead of myself in here. So theoretical probability, what's the event? Defective tablet. In a sample of 7,500 tablets, 80 were found to be defective. So now, if you look at this part over here, can you see the word sample? What they did is they physically take the tablet, inspect it, and then they found that 80 were defective. So in this particular case, because they're actually sampling, they're taking samples of the tablets. This is actually showing us that they're going through the trials. They're trying them. So this is an experimental probability that they're describing here. Okay, so having said that, what's the question here? State the experimental probability of the tablet to 3 decimal places. So probability, okay, what's the event? Defective tablet. Okay, now because we're talking about experimental probability, we're gonna look at how many are defective that they found. 80, so it's 80. How many are all together? 7,500. So it's gonna be 80 out of 7,500. So this 80 came from how many defective tablets? That's from the experiment. And then this one here, 7,500, means how many trials. So how many actual tablets did they check? Okay, so that's that. Letter B, state the odds against a tablet being defective. Odds against defective, I'll just put that, defective tablet. Now I gotta pay attention in here because it's odds against. I'm gonna start with not defective tablet. Okay, this is this is the event that we're talking about, the tablet being defective. But because we're doing the odds against, we're going to do against that one. So not defective is 2 defective tablet. So how many are not defective? So let's go back. They said there were 80 are defective out of 7,500s. So how many are not defective? That's going to be 7,500 minus 80. So 7,420. And then how many are defective tablet? That's going to be 80. Okay. And last but not the least, number C. Based on state the number of tablets from 7,500 sampled that can be expected to be defective based on theoretical probability. So based on theoretical probability, we know in theory there should be 0.014 tablets that are defective. Okay. Now, within that sample, we can expect within that 7,500 sample, we can expect, you calculate that, 105 defective tablets. Okay, so there should be, because in theory, this is what's the probability, there should be 105 defective tablets. Okay, so that's finishes off our review. So I just want to let you know, thank you for watching, and if there's any questions, you can either send me a message through the blog post, or you can send me a message through the email. If there's any questions that you want me to go over with you, if you would like to do a Google Meet, sometime today, you can email me. We can set up an appointment time when we could both be available to do that. And yeah, well, good luck with that one. Good luck with your reviewing. So just a reminder, tomorrow I will post a test. As per usual, you have 24 hours to do the test. It's open book. Okay, so that's an advantage for you if you are learning at home right now. It's an open book test. You can look at the notes, and yeah, I would ask that you submit your test electronically, and I will post all that information tomorrow. So that's basically it. And any questions, please let me know, and I will try to get back to you as soon as I can. Okay. Have a wonderful day, and it's a beautiful day outside. And like during your schoolwork, I hope you just go outside for quite a bit and take some fresh air, get some vitamin D, sunshine vitamin. And yeah, I will talk to you tomorrow, or maybe later if you email me. Okay, have a great day, everybody, and thank you again. Bye for now.